Have you ever looked up at the sky after a rainstorm and seen a rainbow? It's one of nature's most beautiful sights, a perfect arc of brilliant colors that seems almost magical. But what if I told you that the magic of a rainbow is actually a fascinating display of physics? Today we're going to pull back the curtain and explore the incredible science behind how rainbows are formed. It all starts with two simple ingredients: sunlight and water droplets. You'll almost always see a rainbow when the sun is behind you and it's raining in front of you. That positioning is key. Sunlight might look white to us, but it's actually made up of a full spectrum of colors, just like the ones you see in a rainbow: red, orange, yellow, green, blue, indigo, and violet. A great way to remember this order is the classic acronym, ROY-G-B-V. So how do tiny transparent water droplets turn white sunlight into this spectacular color show? Each individual raindrop acts like a tiny prism. When a ray of sunlight enters a water droplet, it slows down and bends. This bending is called refraction. But here is the cool part: each color in the sunlight bends at a slightly different angle. Red light bends the least, while violet light bends the most. After entering the droplet and bending, the light travels to the back of the raindrop. There, it hits the inner surface and reflects off it, almost like a mirror. This is called internal reflection. The light then travels back to the front of the droplet. As it exits the water and re-enters the air, it bends again, a second refraction. This second bending spreads the colors out even further, separating them into a distinct band. Now you might be wondering, if this happens in every single raindrop, why do we see a giant arc in the sky instead of just a bunch of tiny, colorful dots? It's all about the angles. Your eyes can only see the colored light that is reflected from the raindrops at a very specific angle relative to the path of the sunlight. For the primary rainbow, that magic angle is about 42 degrees. Think of it this way: millions of raindrops in the sky are all splitting sunlight into its colors. But from where you're standing, you only see the red light from the droplets that are higher in the sky, which are at the right angle to send red light to your eyes. And you see the violet light from the droplets that are lower in the sky because they are at the perfect angle to send violet light to your eyes. All the other colors fall in between, creating that perfect, seamless arc. This is also why a rainbow is an arc and not a straight line. The collection of all the raindrops that are at the correct angle from your eye forms a circle. We usually only see the top half of the circle in arc because the ground gets in the way. But if you were high up, say in an airplane, you could actually see a full 360-degree circular rainbow. And here's another fun fact: no two people see the exact same rainbow. Because the rainbow you see depends on your unique position relative to the sun and the raindrops. The rainbow you witness is yours and yours alone. Your friend standing right next to you is seeing a slightly different rainbow created by a different set of raindrops. Have you ever been lucky enough to spot a double rainbow? That's when you see a second, fainter rainbow outside the primary one. This happens when the sunlight reflects not once, but twice inside the water droplets before exiting. This double reflection causes the light to exit at a different angle, around 51 degrees, and it also reverses the order of the colors. So in a secondary rainbow, you'll see red on the bottom and violet on the top. So the next time you see a rainbow, you can appreciate not just its beauty, but also the incredible dance of light and water happening in the sky. It's a perfect example of how science can make the world even more wondrous. Thanks for watching, and don't forget to like and subscribe for more amazing science. See you next time.